Hello, everybody. So today we're going to move along section 2 in our finance unit. We're going to finish it up today. So if you remember, the last thing we took a look at last week was compound interest, but this time we were taking a look at problems that were being compounded over periods that were different than 1 year. All right, so here, remember, we have our semi-annually, which is twice a year, quarterly, which is 4 times a year, monthly, of course, that's 12 times a year. And we did some examples, and essentially what we found out is the more often you compound something, the more interest you're going to get out of it, right? So with everything else being the same, in the first question here, we saw $4,207.66 for an annually compounding period, and then it got increasingly larger the more often we compounded it, right? So we're going to move along. So we saw how to do it by hand, right? We're using the same formula, our compound interest formula here, except our I and our N values change slightly when we compound things that are shorter than 1 year, right? So remember our I value was the interest rate per compounding period. So we take our annual interest rate divided by how often we're compounding in a year. And then the N value was how many compounding periods, which is our number of years times the compounding periods in that year. So we saw how to do it by hand. And now what we're going to do is we're going to take a look using our TVM solver that we saw in the last section. Okay. So now we're going to be changing our compounding periods per year because that's what happens when we do problems that compound differently than a year. Okay. So we could take a look at this one here. It should be pretty straightforward. So we're investing $3,000 for 5 years into some account or some investment that pays an annual interest rate of 7%, and this is compounded quarterly. So remember, that's 4 times per year. Okay, that's what quarterly means. And the question's asking us to determine the value of the investment at the end of the term. So I brought up the TVM calculator that I use, and I've entered some values in already, so we can kind of break this down a little bit here. So the present value, the first entry here, that should be pretty straightforward. Of course, we're getting this. That's our principal amount. That's our starting value. Okay, notice how it's negative because this $3,000 is leaving our pocket going into the investment. Okay. Payments, it's left at 0 because the only money we've put in to this investment is the $3,000. We haven't added any more to it over the course of the loan. We're going to see an example like that later, but for now, this is no additional payments. Okay. The future value or the final value, of course, that's what the question's asking us to find. That's our X value, if you will. So we're going to use that button to solve for it here. Our annual interest rate as a percent is 7, just taken right from the question. And now the two things that are a little different are the bottom two. So the periods here I have is given as 20. So how did I get that 20? Well, but before the number of periods was equal to the years, only because we were compounding yearly or annually. But now we're compounding 4 times in a year. And in this question, we're waiting for 5 years. So if every year contributes 4 periods, and there's 5 years, that's just going to be 5 years times 4 compounding periods per 1 year. Okay, so that's 4 times 5, which of course just gives you 20. 20 periods over the course of the entire investment. So that's what goes there. And of course, we're compounding quarterly. Okay. So we can go in. I have this entered already to my account or to my computer. Hit that button so we get an answer of $4,244.33. At the end of 5 years, which should be what we got up here. So quarterly was this question. And as you can see, those are the exact same values. So life is good. Okay. Let's take a look at a different one. And we can fill this one in together. Menuet would like to invest her money so that she will have $9,000 in 5 years. The bond she would like to invest in predicts that an annual interest rate. The bond she would like to invest in predicts an annual interest rate of 2.75%, and that's compounded quarterly. How much should her initial investment be? Okay, so this one's a little different. And the way that it's different is in the previous question, we knew how much we were starting with. We wanted to know what we ended with. In this question, we want to end with a specific value, and the question is how much money should we put in to start with? Okay. So what we're being asked for here, our x value, is the initial value, the present value. Payments. Are there any payments being made in addition to the initial investment here? The question doesn't mention anything like that. So this is going to be 0. The future value or the final value. We know that we want a payout at the end of the year to be $9,000. Okay. And that's going to be entering our pocket, if you will. So it's going to be a positive value. Okay. The annual interest rate from the question says it's 2.75%. So we can leave it there. Remember, this particular calculator wants me to leave the interest rate as a percent. Some might require you to put it into a decimal. Just keep your eyes open for that. And now the amount of periods. Okay, so we have to do the same calculation we did before. So how many years is it sitting? It's going to sit for 5 years. Okay. Times how many compounding periods in a year. So this one is being compounded quarterly again. Okay, so quarterly means 4 times a year. So again, we're going to have 20 compounding periods. And this is, of course, going to be quarterly here. Okay, so we can go and enter that in. So this one we're going to leave blank, no payments. Future value is going to be 9,000. The annual interest rate was 2.75 or 2.575. And 20 is going to be the periods compounding quarterly, so I'll go up, I'll hit the PV button here. And we get a value of $7,847.50. Notice again that it's negative. This is just the solver telling you that that is the money you will have to put in. This is money you will be losing as you put it into the investment, but you will get $9,000 back. So it's about $1,250 return on your investment. Okay, so the payments, or the present value, the initial value, will be, what did I say, $7,847.50. Okay. So that's using our TVM solver instead of doing our calculations by hand. All right, so let's move along to something new we're going to talk about. So anytime you make equal payments to something in general, or somebody makes equal payments to you. There's a special name for it in finance, and it's called an annuity. Okay. There's lots of different kinds of annuities out there. Some examples that I've listed here. For example, it's a good idea to keep a savings account. When you get older and you get a job, you should put a little bit of money away every time you get paid. So for me, for example, as teachers, you don't get paid in the summer. So every time I get a paycheck from the school district, I make sure that I take the same amount of money and I put it into my savings account so I'll have enough money to pay my bills during the summer. So as long as you're paying the same amount each time, you would call that an annuity, right? If you have some sort of loan, like for myself, I have student loans, so I pay the same amount of money to those every month. That's an annuity. And also, when you retire and you collect your pension, they'll usually pay you the same amount of money every month or every 2 weeks. So another way to refer to those is you just call it an annuity. Okay, so why are we talking about annuities? Well, previously we were talking about problems where we just put in the money and we let it grow and we didn't do anything else other than watch it. Now what we're going to do is we're going to put in some initial amount, and then instead of just letting it grow, we're going to put in a little bit of extra money every month or every whatever. Because the more money we put in, of course, the more money we're going to get out, because interest is a percent. It's not a flat value. The more you put in, the larger the percent of that thing is going to be, right? So I just have a note here that while we regularly add to our investment, we can start with a principal value, or we could not start with a principal value. Either way is fine, okay? If our PV value is 0, that means, and remember the PV value is our starting amount, our principal. If our principal amount is 0, all that means is that that means that the investment we're making is made up of only these regular payments, these annuities. If our principal amount is non-zero, then we started the investment with some sort of initial payment, and then we've added the annuities on top. So we can or we cannot have a principal value. Either way is fine. Okay. So let's take a look. Byron invests $600 into a savings account quarterly. So that means he puts in $600 every quarter. So remember, quarterly, that's every 3 years. Okay. If this account pays 7% interest per year compounded quarterly, what is the value of the investments at the end of 3 years? Okay, so the first question is there an annuity involved in this scenario? In this case, yes there is, because he's making regular payments of $600 every quarter. Okay. So now the question is, what is the PMT value below? All right, so notice in the question that we didn't start with an initial principal value. We didn't start with an initial sum for the investment. Okay, all we're doing is making $600 payments. Okay, so we're going to set the PV value or the initial value to 0 here. Now we're going to use the payments section. So we already know he's making $600 payments. Those are payments that are leaving his pocket and going into the investment. So we're going to leave it as negative. The final value, or the future value, we're going to get to. That's what we're trying to find. The annual interest rate from the question is 7%. Straightforward. The periods is 12. Why is it 12? Well, if it's compounded quarterly, that's 4 times a year, and we're letting it sit for 3 years. So that's 12 periods total. Okay. So that's how we get that. And we know that the interest is being compounded quarterly. So note here that we've set the mode to the beginning. Although the question doesn't say it, we're assuming that he's going to be paying the annuity at the beginning of each month. Okay, or sorry, the beginning of each period. The start of every 3 months is when he's going to make that payment. If he was making it at the end, we would put the mode at end. Okay, so let's go in. We can do this here. So we'll set that to beginning. The present value is going to be 0. The payments, negative 600. The future value we're looking for, I think that was 7%, right? Yeah, and then 12 is being compounded quarterly. So now if we want to see what the value of that investment is going to be at the end of the 3 years, we can just hit our FV button and we'll get our value there. So $8,073.93. Pretty good. So what did I say? 8,700 or 8073.93. All right. Hopefully that's pretty straightforward. Do I have another example here? I do. All right. It's a long example, but it's a good example. So let's take a look. Okay, Banker Bill, he's going to set up a fund for his 2 granddaughters, Becky and Bonnie. The girls had a choice between 2 options. So the first option is their grandpa is going to give them $2,000. That's going to be invested on each birthday between age 27 and age 64 inclusive. So that means it includes the 27th and the 64th birthday. And the money is going to stay into the account until the age of 65. And the other option is that $2,000 will be invested on each birthday between age 19 and 26 inclusive. And then the money is going to stay in the account till the age of 65. Okay. So both options will receive an interest rate of 10% per year, compounded annually until the age of 65. Becky recognized that more money will be invested under option A and chose this option, but Bonnie chose option B just to be different from Becky. Wow. How many payments were made on Becky's behalf? How much money was invested for her? Okay, so let's see here. Just want to make sure I'm going to do this correctly. Okay, so for Becky, she chose option A. All right, so on the 64th birthday minus the 27th birthday, right? So that means we should get 64 minus 27, which gives us an answer of, wait, hang on, sorry. $2,000 will be invested on each birthday between, so that's going to be, this is 37, and the money's going to stay until the age of 65, so we have to add 1. So that's going to be 38 payments. And if $2,000 is going to be invested every year, that means it's going to be 38 times $2,000 So it's going to give us a total of $76,000. And for Bonnie, so we get 26 minus 19. Plus the initial payment, so that's going to be, well, that's 7 plus 1 is 38. And this one is 7, and we get 7 plus 1 gives us 8 payments. And for this one, of course, that's going to give us 16,000. Right? Okay. Oh wait, hang on, sorry. What did I do? How many payments were made on Becky's behalf? How many payments were made on Bonnie's behalf? Okay. How many payments were made on Bonnie's behalf? How much money? Oh, I think I accidentally copied that twice. Okay. At age 65, what was Becky's investment worth? Okay. Sorry. So the end value, which was the number of years, it's going to be 8. The investment, or the interest rate was going to be 10. The initial value was 0, right? Because we were doing our annuity. Their grandpa was just doing an annuity every year. There was no initial sum. Here, the PMT is the payment amount. So grandpa was putting in $2,000. The final amount is what we're going to be looking for. The payments that he was making per year was just one payment every year. And this is compounding periods per year. So if you remember, the account was compounding annually. So that's once per year. Okay. And we're assuming that he's paying at the start of each birthday. So we would put that in to our account, or to our calculator, and we would find that the final value here would be $25,158 and about 95 cents. Okay. Wait, what am I doing? Sorry, that was Bonnie's. Sorry. Yeah, I'll just copy this over here. Sorry, I just did Bonnie's and Becky's. Sorry about that. Final value 25,000. 158.9511 begin. Okay, well let's finish Bonnie's then, I guess, while we do that. All right. So this was the value on the 27th birthday. Okay, and then from there, it sits in her account until the age of 65. Okay, so now the final value at the end of her 27th birthday becomes the principal value, or the initial amount, while it sits there in the account and grows, right? And now, if that was the end of her 27th birthday, it's going to take another 38 years to get to 65. Interest rate stays at 10%. The payments stop. Grandpa's not putting in any more money. The final value, we're going to find out. Again, there's one period a year and one compound a year. And then this one is going to be at the end. Okay. So this one's going to be 94,000. Sorry, 941,000. and 1 cent. And this is at age 65. All right. Okay, so let's do Becky's. So for this one, it was 38, right? All 38 years. And the investment was 10. The principal value again was 0 because Grandpa was just making payments of 2,000. And it was 1 payment a year at 1 compounding period per year, and Grandpa's making payments at the start of the month, we'll assume. Okay, so if we punch that in, we get an answer of 800,000. $895.56. Okay, so we can see that Bonnie actually ended up with more money. So what does that mean? What can we conclude from this? Well, essentially what we get here, because let me see, let's take a look at the differences, right? So Bonnie invested the money much earlier, right? She took option B. She invested at the start of age 19, whereas Becky invested at the age of 27. But the main difference other than that was that Becky was getting payments until she was 64, and at the age of 65 she took the money out. But Bonnie, she stopped payments much earlier. So although Bonnie stopped getting payments from Grandpa to her account much earlier than Becky did, because Bonnie started accumulating that money earlier, that interest outpaced the amount that she was getting from Grandpa in those extra years. So it was 7. So there was an 8-year difference between the initial investment, right? Grandpa gave Bonnie the money 8 years sooner. So the extra money from those, the extra interest from those extra 8 years ended up being more money than having those $2,000 payments from Grandpa over the longer period of time for this one. Okay. So what conclusion can we make? Basically, investing early in life can, or what should I say, investing early in life can produce interest that, what should I say? Yeah, outpaces that outpaces larger sums of money. That outpaces contributions. All right. So although although Becky got a larger sum of money gradually over time from her grandpa compared to Bonnie, because Bonnie started so much earlier, the compound interest she was accumulating in those earlier years ended up being more valuable than the money Grandpa was giving to Becky for longer periods of time. Okay, so hopefully that makes sense. So let's see, what questions do I want you guys to do here? We can just do the rest of the questions, I suppose. So, let's see. So the assignment starts on page 515. So I think I just had you guys do up to question 2 last time. So we'll do questions number 3 to 12 now. Okay, so go ahead, get started on those, try your best. If there's any issues or you have any questions, please email me or contact me through the Discord. Remember, I'll be available every Monday and every Wednesday from noon till 1. If you have any questions, we can voice chat over Discord and I can help you guys out, okay? So stay safe out there and I'll see you next time. Bye.